Hey there, welcome back. So today we will check the comparator interface. Now we have already seen the comparable interface. Now when it comes to comparable interface, there is only one type of data which we can compare, or to be very specific, we can only have one property, for example T type, and then we can compare. With comparator, we can have custom type of comparison, and we can also make use of multiple entities like key value pair. So in here, in this class, we will have the key value pair, and let me create the constructor for the same. So the key value pair would be there, and we will create constructor, and let's also create getters and setters for the class. I will right click, navigate to source, and generate the getters. For this class, we will require only getters, not setters, and let us also create the toString method. Alright, so moving forward, let us create a set. It would be a set of data. Data is our class, and we will make use of linked hash set. Let us add couple of entries, and note that we haven't specified any data type. So as if now we will firstly add string. String would be like key and value to make things very simple. And then moving forward, we will add couple of more entries. So let me copy the statement. Let me paste it couple of times. In place of key, let me add 1. And in place of value, let me add in 1 as a string. Let me copy the statement once again and paste this couple of times. And then we will make the key as 5 maybe. And we will make the text as 5 again. Let me repeat the step and make the key as 9 and make the text as 9. Let me repeat the step couple of times. Alright, so here we go. So we have added couple of entries, and now we will create a quick for each loop. The loop would be based on data. The temporary variable name could be like element, and the iteration would be based on our set. And then we will simply output the result using system.out.println, and we will try to print element. Here we go. Alright, so there is a typo. Let me fix that. So now we can try to print the values, and here is the output, which is fantastic, right? So we are able to print the information on the console. Fantastic. Now friends, we have created the set, but there is a issue. For example, we make use of tree set and then we try to execute this particular program, then there would be an issue. Why? Because in tree set, we sort the things and then store, but in order to sort the things, we don't have anything. We don't know how to sort things. I guess there is some compile time error. Let me fix that first. And now if I rerun the program, now we will get a proper error, and this error is based on comparable interface. Let me maximize this and show you properly. Here we go. So the issue is based on comparison. The sorting is not going well because Java doesn't know how to sort this complex data. Now friends, in the current scenario, we won't be able to make use of comparable. Rather, comparator is a better match because comparable is not capable of handling key value pair or more than one entity. So in here we have key value pair, 2 entities to be handled, so we will make use of comparator, and comparator gives us an opportunity to add multiple sorting option as well. So that's again one thing. So in here we will create an object by the name of compare underscore key, and in here we need to override a compare method. So definitely we will also make use of inner class. So in here, let me create an object of comparator, and in here we are overriding the compare method. So in the compare method, we will add some custom logic. Now friends, comparison could be done on similar type of objects only. So in here we need to infer the arguments of the diamond operator. So the argument would be based on the type. Key would be integer and the value would be string. So let us get rid of all the warnings which are there in the program, and we will infer the arguments real quick. Let me provide these to all the data which is there in the set, and as soon as we do that, there would be one error, and the error would be based on the first entity where we have added the data string. So let me delete that, and in order to fix the remaining warning, let me also add in the argument, and now all the warnings except one is gone. The last warning is because we haven't made use of compare key. Even now, if I execute the program, there would be an error based on comparable interface. Now finally, let us fix this. Now friends, moving forward, let me make a small little change. In place of O1, let me make it as obj1, and in place of O2, let me make it obj2. Alright, so in here, let me add in a condition. If object1 dot get key, so the value of key is received, and if the key 1 is smaller than key 2, then we will return -1. So I will type in obj2 dot get key, and that's it. Alright, and let me add in the pair of braces, and in here we will return -1. Alright, let me repeat the step, and this time we will make use of else if. Let me paste the condition, and this time if object1 dot get key is greater than object2 dot get key, then we will return 1. Alright, and else we will return 0. So this seems to be good enough. I guess there is a typo. Let me fix this. Alright, so everything looks good to me. Now we will pass the name of the object to tree set, and now if I execute the program, tree set will make use of this comparator, and it will compare the objects, and here is the output, which is perfect. And the comparison is based on key, and as we can see that the sorting is done properly. Alright, so this is good, and note that the value 5 is not repeated as well. Alright, so moving forward, let me do one more thing. Let me change the values. Let me add some names in here, like Chand, then the second name could be like Ed, then maybe John, then let me add Arnold space J, and lastly let me add in Mike. So I suppose this would be good. Let me make Mike as Mia, that would be better. Alright, now moving forward, let me copy the code of comparator and paste it once again, and now we will create a custom object, a different object, and we will change the name to compare underscore name underscore length. So this comparator would be based on name length. Alright, let me get rid of the previous logic, and now we will add a custom logic real quick. So I will type if object1 dot get value dot length is less than object2 dot get value dot length. In this case, we will return -1. Let me repeat the step. Let me type in else, and let me copy the statement, and we will make the less than operator as greater than operator. That will serve our purpose. Alright, and if this is the case, then we will return 1, a positive number. And if both the conditions are false, then we will definitely return 0. This means that length of both the names are same. Alright, so this is cool. Let me try to format this a little. Alright, so now everything looks fantastic. Let me do one more thing. Let me make use of compare name length in place of compare key, and now the tree set will compare based on compare name, which is good. Like, so the comparison is based on name length, and Ed is first, Mia is second, and Arnold J is the last, which is fantastic. Let me copy Chand and paste it once again, and as this is a set, the name Chand will not get repeated, which is fantastic. Alright, so this is it, how easily we can have custom ordering, and we can have multiple ordering options as well. So this is fantastic. Thanks for watching.